Welcome back to the Watershed Wise Landscape Professional Certification. This is Module 6. We're going to be talking about irrigation scheduling, and we're going to continue talking about irrigation scheduling. And now, this is the meat. This is the meat of irrigation scheduling. I mean, you're going to be able to program an irrigation controller after this. It's pretty cool. This is called Total Irrigation Run Time. So we're going to go where we left off before, was interval days, right? How many days between irrigation events? And now we're going to figure out how much water do we have to apply when we actually irrigate, and how long in minutes is it going to take us with this irrigation system to deliver that water? Pretty cool, huh? Okay. So, after you have determined the irrigation interval, and remember, you've rounded up when you did that, there's a little thing that has happened because you no longer have only depleted the allowable depletion from the soil, right? Because the allowable depletion was based on, that was the number of, that was the amount of water that was depleted from the soil in a period of days, but because you were taking that out of some amount of water that was already in the soil, it's possible that you had to round up your interval, and now instead of 5 days between events, you have 6 days between events, and that means you have 1 extra day of evapotranspiration that has happened. So once you calculate your interval, you are then going to calculate your actual water requirement, all right? The actual water requirement is going to change with this adjusted interval that you have. Now, this it's not a big deal, when you're rounding up and you have 1 extra day, because, it's like going to be like 0.125 inches of water that's coming out of the soil. That's not the big deal. The big deal happens when you have restrictions on your irrigation. So let's say you can only irrigate once a week, or let's say that the landscape has to be dry for 4 days because there's some big soiree planned. So they don't want any irrigation for 4 days before the soiree. Those things are going to actually change the interval between irrigation events. They're going to add time to the interval. And you know what? Because you used a 50% MAD when you did your original calculations, it's all cool if you're going to go a couple extra days. Not a big deal, right? You just stay relaxed because you only allowed 50% of the water to be depleted from the soil in your original calculations. If you have to add a couple days to that, and you allow a little bit more to be depleted, it's okay. You're not pushing up against a wilting point. Don't worry. But this is the thing. You are adjusting your interval because of a variety of things. So now you have to figure out what is the actual amount of water that has come out of the soil. And this is called the actual water requirement by those plants. And the way that you calculate it is you take your actual or adjusted interval days and you multiply it by the daily plant water requirement. This is going to tell you how much water really came out of that plant available water reservoir. And so, in the case of a delay, let's imagine that you calculated your interval to be 5.23 days. Okay. Now, you know 5.23. Okay, what do you know right away? It's not 5 days, it's 6 days. That's your new interval. That's the first adjustment that you've made to the interval is that you've gone up to 6 days. So 6 days, if you could water on that day, on that 6th day, the amount of the actual water requirement would be 6 times the daily plant water requirement. And that would be the amount of water that would be required by the landscape. But it turns out that you've got a delay, you've got a party, coming up. And so there are going to be 3 days that you cannot irrigate. And so that's going to add to your interval. So instead of it being 6, you're adding 3 days, it's now 9 days of interval. So the actual water requirement at this time is going to be 9 days times the daily plant water requirement. And that's the amount of water that is actually going to be required to be put back into the landscape because the plants have taken it out over those 9 days. So after a 9-day interval, we are going to irrigate, and we need to figure out how much water do we have to put on the landscape in order to get the actual water requirement in. You with me? Hope so. Okay. This is going to depend on what do you think? I mean, you can see right here. What is the thing that always makes us have to apply more water to the landscape? Well, we have an irrigation system. And what do we remember about irrigation systems and their efficiency? That there's no such thing as a 100% efficient irrigation system. So because we have to add the water onto the landscape through an irrigation system, we need to now figure out what is the irrigation water requirement. We know what the actual water requirement of the plants is. We got that figured out. But now, how much water are we going to have to put on the landscape in order to make sure that the actual water requirement is, met? And that's called the irrigation water requirement, or IWR. And in order to come up with this, we take our actual water requirement and we divide it by the irrigation efficiency of our system. Now remember, this is just like, remember we talked about this in plant water requirement, right? We went through the whole thing of why do we divide and all that sort of thing. And we remember that we have to, when we adjust for an irrigation system, we are dividing by irrigation efficiency because we're always going to have to apply more water to the landscape in order to get the amount we actually need on the landscape, because we're doing it through an irrigation system, and that irrigation system has some amount of efficiency, and it's less efficient than 100%. So what would be the irrigation water requirement if our distribution uniformity, remember distribution uniformity and irrigation efficiency are basically the same. So what would be the irrigation water requirement if our distribution uniformity was 60%, as it shows here in this question? And we have 9 days is our adjusted interval, and every day 0.125 inches of water are coming out of the soil. So first thing that you would do is you would figure out the actual water requirement. How much do these plants actually need? You take the interval days of 9, multiply it by daily plant water requirement. That's going to tell us the actual water that is required. And then we would divide that number, the actual water requirement, by 60% or 0.60 to find out that we would need some inches, some amount of water to be applied to the landscape. And in this case, it would be 1.875 inches of water. Let's see, hold on a second. Let's just go back here a second. So we calculated previously that the 9 days gave us 1.125 inches. That's how much the plants actually need. But now, because we divided by this 60% efficient irrigation system, we have to actually apply 1.875 inches to the landscape to get that 1.125 onto the landscape. Okay. So now that we understand how to calculate our precipitation rate, we're going to come back to total irrigation run time, because in order to calculate our total irrigation run time in minutes, we needed to know how quickly the water was being applied to the landscape by this irrigation system. So total irrigation run time is essentially taking the irrigation water requirement in inches. That's how much water we need to get on that landscape, and dividing it by the precipitation rate, so how quickly that irrigation system is applying it. And the formula for total irrigation run time, which is again minutes, is the irrigation water requirement in inches times 60 minutes per hour. So this is basically converting that that irrigation inches into inches, irrigation water requirement inches into inches per hour, and divide, or inches per minute per hour, and dividing it by precipitation rate in inches per hour. And what we get then is the minutes that we have to run the irrigation system for in order to apply that irrigation water requirement. So in our example, we have a precipitation rate of 0.75 inches per hour, and we have an irrigation water requirement of 1.875 inches. And when we put that into the formula, we find out that we need 150 minutes to run this irrigation system that is applying water at 3/4 of an inch per hour in order to get that 1.875 inches of water delivered onto the landscape, so that we get the the actual water requirement that the plants need. And we've done this 150 minutes every 9 days. So every 9 days we are applying water in this scenario, right? Next time it might be a shorter interval because we don't have to wait for the party, next time. But this time it took 9 days. And after those 9 days, we are going to apply our irrigation water requirement, and it's going to go down in 150 minutes when we use this irrigation system. So that's the amount of time we're going to need to get that water down. So let's quickly review the steps to total irrigation run time. We determine the soil type because we need to know the soil moisture reservoir. So soil type and the available water holding capacity per soil type. We multiply that by root depth. That tells us how much water is in the soil moisture reservoir. And that is also called plant available water. Okay. Then we determine our managed allowed depletion. What are we going with industry standard of 50%, or are we going to do something else? Let's say it's 50%. We apply the managed allowed depletion percentage to our plant available water, and we come up with the amount of water we're going to allow to deplete from the soil in inches. So this is our allowable depletion. That's how much we're going to allow to go away before we irrigate again. Meanwhile, the plant is in fact taking water out of the soil. It is every day taking the daily plant water requirement out of the soil. And at some point, that amount of water, the sum of the amount of water that it's taken out of the soil, is going to be equal to the allowable depletion. So we take the allowable depletion and we divide by the daily plant water requirement, and that tells us how many days, what is the interval between irrigation events? How many days between the irrigation events? If that number is a decimal that's higher than a round number, we round up. Only time you're ever going to be thinking about that. And that number multiply, and then we make adjustments. There may be an adjustment like a party, or you can't irrigate on a Wednesday and it just happens to fall on a Wednesday, or whatever it is, right? You're going to adjust that interval for anything else that you need to adjust it for. But now you have your interval. You know that you're going to irrigate, on some number of days between the irrigation events. In order to determine how much water the landscape requires, you're going to multiply the interval by the daily plant water requirement to figure out the actual water requirement. How much is actually needed by this landscape? Once you've done that, you're going to divide the actual water requirement by the distribution uniformity or irrigation efficiency of the system in that site, because we know that no system is 100% efficient. There's going to be some amount of water that's not going to make it onto the landscape. So we divide by that distribution uniformity, and this tells us our irrigation water requirement. How much water does this system actually have to put on the landscape to get what we, to get the actual water requirement to the plants. Now, to figure out minutes, we have to take a little detour and figure out our precipitation rate. If it's a precipitation rate of spray heads, straightforward, we add up the spray heads, get the gallons per minute, get the total square footage of the zone, we can figure it out. If it's a random pattern of drip, also pretty straightforward, add up the emitters and do the same thing. If it's a grid pattern, we have a different precipitation rate calculation. It's dependent on the flow rate of the emitters and the spacing of the emitters within the tube and between the tubes. And that will help us determine precipitation rate. We take our precipitation rate, which is always expressed in inches per hour. And now we have the information to figure out how many minutes is it going to take us to apply the irrigation water requirement to the landscape. And that is our total irrigation run time. Voila. That's a big deal. That, I can't tell you how many people can't do this, and they certainly can't do it on the back of an envelope, which you will be able to do in very short order. Now, what happens when you are applying water to the soil at a precipitation rate that is faster than the water can be absorbed by the soil? You get runoff. So when the precipitation rate of the irrigation system exceeds the intake rate of the soil, runoff occurs. This is called dry weather runoff because it's not raining, we're irrigating, presumably, right? it's irrigation and it's a dry day, but that water's not making it onto the soil. It's running off the soil. And this is something that we want to try to minimize. So actually, this is really a key component of irrigation efficiency, is adjusting to make sure that the irrigation is spraying the landscape and not somewhere else. But also, we can adjust the irrigation runtime in order to give the landscape a chance to absorb the water. So this is probably particularly true in a clay soil scenario where you have a very, very low intake rate, but and if you have spray, your precipitation rate is almost guaranteed to be higher than your intake rate. Oh, by the way, it's very easy to get a grid drip irrigation precipitation rate higher than the intake rate of soil, especially in clay. So watch out for that. That is, people say you can't get runoff with drip irrigation. Hey, no. You can easily get it. If you have a 12-inch grid, a 1 or more gallon per hour emitter on a 12-inch by 12-inch grid, you are definitely putting down way more water than a clay soil could intake. So FYI. Anyway, back to the real story. So we want to figure out, how do we take our total irrigation runtime and make it so that the soil could absorb the water, and so we are actually applying that water to the landscape. And this is called cycling and soaking. I want to just mention that dry weather runoff is a major pollutant. This is a really, really, really big deal. First of all, dry weather runoff is a water waste because that water is not going on the landscape, okay? And every day there are hundreds of millions of gallons. I mean, if you remember, WaterSense says that there are 9 billion gallons of water that are going into landscapes, and half of that is wasted. So 4.5 billion gallons of water every day. Oh my gosh, that is huge. Is running off and not getting onto the landscape. And that's drinking water, folks, in most cases. So we want to make sure that when we are looking at our irrigation system, we observe it to figure out, when are we getting runoff? Are we getting it, first of all, and when? Like, how long does it take? And that time is going to be the maximum irrigation runtime. You cannot run your irrigation system for longer than that because you will get runoff. So if you're on a clay site, for example, with a spray system could only be running for 3 minutes and you might then be seeing runoff. That 3 minutes is your maximum irrigation run time. That's it. You cannot run it in any, in any event more than 3 minutes. So what do? I mean, what if you've got, a 30-minute irrigation runtime, right? Total irrigation runtime, and you're only allowed to, you can only really apply the water for 3 minutes before runoff. What do you do? Well, what you do is you come up with cycles. And the way you determine the cycles is you divide the total irrigation runtime. Oops, let's see. Oh, no, I'm just going to talk about it. You divide the total irrigation runtime by the maximum irrigation runtime. Okay, so that's your runoff time. And that's going to tell you how many cycles you need. And the cycles would be 3 minutes, in this case that I just talked about, it'd be 3 minutes of running and then a break, let's say half an hour, and then another 3 minutes and a half an hour. So you can see why, from an irrigation point of view, focusing on creating, first of all, very efficient irrigation, yes, of course, but creating soil that has a different intake rate, right? Now, you can't change your soil. If you have clay soil, you have clay soil. You don't change the type of soil that you have. You change the structure of the soil. And that is why living soil is so important to us in irrigation and anything having to do with landscape, but especially in irrigation. But because we're talking about irrigation science right now, we don't consider soil structure. So just soil type, clay soils, you have a very low intake rate. And you can see there's a chart that's also in your coursework that shows you the calculated intake rates of various soil types. So if you have sandy soil, very sandy soil, your intake rate could be as much as, 20 inches an hour. I mean, you could literally have a sieve, which is bad. Oh, by the way, there are only a few cases where you would want that. Certainly not a planted case where you would want that. But, maybe there's like some kind of municipal infiltration that's going on. Okay, yeah, great. You have this fast infiltration rate. And then on the other hand, you have very fine soils like clays that are infiltrating at 0.06 inches per hour, 0.06 inches per hour. Yeah, there's almost no irrigation that you could apply that would only be applying at 0.06 inches per hour. So you definitely need to be aware of the type of soil that you have in order to just have an inkling of the absorption rate. But then you observe how quickly you are getting that runoff, and that will help you to calculate the number of cycles that you need. And remember, cycles are the maximum time to runoff, rather the total irrigation run time divided by the maximum time to run off. And that's going to tell you how many cycles you're going to need to create. So one way that you can deal with irrigation scheduling and timing and all that sort of stuff is to actually utilize a weather-based irrigation controller. The weather-based irrigation controller, when you input the correct data into it, you get a controller that is using the weather data to change the schedule. So that all sounds really quite magical and wonderful. And they are, in general, weather-based irrigation controllers are great because, they take into account things like cloud cover and all that sort of stuff. Where you have issues with weather-based irrigation controllers is the input of the info. So you definitely want to be clear on what your precipitation rate, you want to be clear on what your soil type is and the irrigation type and so forth. So you really need to make sure that the inputs are good, but if they are, a weather-based irrigation controller will help you to manage the efficiency of the application of water to your landscape. But now you can calculate the total irrigation runtime and put at least the baseline program into any controller. So that is the conclusion of irrigation scheduling.